Again, we're just going to revisit Math 12 or Pre-Calc 12 final exam practice. So here is we have a graph. They want us to sketch at least one period of the function. So the first thing when you want to graph, the first thing you do, you find the period. And the period is always 2 pi over b, and b is right after the cos, which is the half right here. That represents b. So 2 pi divided by half, and that gives you 4 pi. Now, once you find the period, you really what you did, your horizontal stretch, you know what that is. Usually I like to find my scale, and the scale is the period over 4. I'm not going to find the scale with this one because everything is obvious, but let's say the period that you were graphing, the period was 2 pi over 3, then you really have to have a scale so you could see where everything falls. But this one is straightforward. So the period here is 4 pi, and the amplitude equals 1. So the way I graph, you know, every teacher graphs differently and everybody graphs differently. But for me, when I graph, I find the period and the amplitude, and I find if it's reflected. You know, if there's a negative in front, then, you know, a maximum becomes a minimum becomes a maximum. But here the amplitude is fine like that. So I'm just gonna scale here. I forgot to scale 1. So I'm gonna graph a full period of 4 pi and amplitude of 1. So if the period is 4 pi for cos, remember the cos, a full period is usually between 0 and 2 pi. Pi being in the middle there, and pi over 2 being quarter point, and 3 pi over 2 is 3/4 point. And it's between 1 and -1. That's what the range of it is. So it does this. So that's your standard graph when you're graphing this kind of graph. So that's what you'll be looking at. Except now, the amplitude is still 1. So it starts at 1 for sure. But the period is 4 pi. So the end point is not going to be at 2 pi. It's going to be at 4 pi. Obviously, the middle is going to be at 2 pi. And then I have my quarter point is always right in between my start and my end horizontally. So it should be at pi, and that's your 0. And also your 0 right here is going to be at 3 pi. That's the 3/4 point, which falls on the x-axis. After that, now I'm going to look at the shift. Okay, so the phase shift. So this graph shifted left, pi over 2, and down 3. So you take each point here, and I'm just to let you know, this is pi over 2, pi, 3 pi over 2. That's negative pi over 2. So now since the graph shifted pi over 2 to the left, you take those main points, you shift them pi over 2 to the left, and then you go down 1, 2, 3, and you have your first point. This one also shifted pi over 2 to the left, and then down 1, 2, 3, so it goes right there. And then take this one, shifted pi over 2 to the left, and then down 1, 2, 3, it goes right there. And this one shifts pi over 2 to the left and goes down 1, 2, 3, so it goes right there. And then the last one shifts pi over 2 to the left and goes 1, 2, 3 down, and it's right there. So your graph would look, if you're graphing one period, it would look exactly like this. That's a full period. Kinda, it's not the best curve, but it's supposed to be more like this. That kind of thing. I'm just ignore that part right here. So that's how you graph sinusoidal functions, either sine or cos. So this is a full period. So again, just to repeat, I find the period and then my amplitude, and if it's reflected over the x-axis, I put my points for a full period, and then the translations, which is pi over 2 to the left, my phase shift, and my vertical displacement is 3 down. I just do that last. And you know, if you remember the transformation chapter, you do expansion compression first, reflection second, and then the third thing you do translation as last thing you do. So that's why I left translation till the end. So that way, at least you do it in strides instead of trying to do everything all at once. Okay, we'll move on to the next question. So here's a question. The question is asking you, if theta is 4 pi over 3, confirm that 4 cos squared theta minus 1 gives you 0. So the first thing I want to do here, I want to draw the 4 pi over 3. For some of you who don't like dealing with radians, I'll just convert this to degrees. So it's 4 pi over 3 times 180 over pi when you're converting to degrees. So the pi's would cancel. 3 cancels. The 180 becomes 60 because reducing 4 times 60 is 240. So that's your angle. And it's very important to know your angle, because what you want to do, you want to graph your quadrants. 240 happens to be right here. That's how much from 0, 180, 360, 90 degrees, and 270 degrees. All the way here is 240. Of course, you want to find the reference angle right here. Raise the vertical right there. And so 240 take away 180 gives you the reference angle, which is 60 degrees. Now this is 30 degrees. According to the special angle triangle, opposite to 30 is always 1, but it's going to be a -1 since the x-axis here is negative. Opposite to 60 is √3 from your special angle triangle. If you don't remember, just look it up. And then the hypotenuse is always 2. Now, based on that, I'm going to go, okay, 4 cos squared theta minus 1, would it equal 0? For the cos of 240, which is the reference angle 60, is -1 over 2. So I'm just going to sub in -1 over 2 right there. And then it's squared. So I'm going to throw a square right here, -1. Does that equal 0? For when you square a fraction, negative becomes positive. 1 squared is 1. 2 squared is 4. So it's very easy to square a fraction. Just square the top and square the bottom. -1. 4 times 1/4 is 1. -1 equals definitely 0 equals 0. And so it's proven. It's done. Thank you for watching. Don't forget to like, comment, and subscribe, and share with your friends so they could benefit. Bye-bye.